Hello and welcome to Getting Started with Excel, Python, and Machine Learning. My name's Alexandra and I will be your host tonight for our webinar. I'm also the instructor of this course coming to you at the end of February. So welcome all, come on in. Let me know if you can hear me and if you can see the slides on screen. I also dropped a link in the chat to the slides, so you can all follow along if you'd like. You have the link, you can download these slides for later. We're also recording, so we will be publishing this webinar on YouTube, so you can watch it later on YouTube or Circle. So welcome everyone, this is our first time that we're doing this webinar. This is a brand new course, Excel, Data Science, Python, and Machine Learning, newly added to the Lumiwealth site, so very exciting. Thanks all for joining me tonight. Tonight's agenda, first we're going to get to know some of you that are on the call, talk about Lumiwealth, and then we'll dive into 4 topics related to the course. We'll talk about Excel and Python, data science, and machine learning. We'll also dive into an example with code. So the idea is to give you an understanding of some of these topics, a bit more knowledge about them. In the course, we cover these topics in more depth, and the course is project-based. So we build projects every single week. That's the main focus of the course, is through hands-on learning. You can see the whole curriculum if you go to the course page. You can see exactly what we learn each week, and you'll find that there's a lot of projects throughout the 8 weeks of this course. So to begin, I'd love to get to know some of you on our live call. That way I can get to know what level you're at and how much experience you already have. So please let me know, what is your current occupation? Do you know how to code? How much experience do you have with Excel, coding, or machine learning? So feel free to answer whichever ones you'd like. This will give me a better understanding of our level of expertise, because we always want to tailor the webinars and the courses to the students. Usually I get complete beginners, so don't worry if you are a complete beginner. That's what I typically expect, but you never know, maybe some of you have a background. So my name is Alexandra. I am an instructor here at Lumiwealth and also a software developer at Mammoth Interactive. I also teach blockchain programming and Web3 here at Lumiwealth. And I'm excited to bring to you this machine learning course. We're going to build tons of projects using Python as our coding language in this course. So I've taught tons of different machine learning courses before, all the way from simple neural networks and all the way up to more complex ones, from machine learning models like linear regression to predicting stocks to detecting objects and facial recognition. So in this course, we'll start off with the easier projects, but each week we will build upon our knowledge. Okay, so we have one message from Darren, a college professor, some coding experience. Great, glad to hear that you have some coding experience. That will definitely help you with this course. But even if you don't have coding experience, we will start off with fundamentals of Python. You can see in the curriculum around week 2, we do start from the fundamentals of coding for those of you that have never coded before, because I do expect that some students will have no experience. Then we'll dive into an introduction to machine learning with our first project. So every week, except for week 1, but every other week we will be coding. So if you do have experience with coding, that will help you. Definitely build the projects faster and to advance on the projects, make them more complex, and just in general take less time. We also have a comment from Michael, wireless engineer, no coding experience. Right? Yes, usually I expect complete beginners, so that's why we designed the course with that in mind. All right, thanks all for commenting. Feel free to comment away throughout the night and ask any questions and whatever you'd like. The interactive presentations are the best. So here at Lumiwealth, we'll do a quick intro for those of you that have never had any of our classes before, here at Lumiwealth, we are an online school where we have a bunch of courses, primarily in the financial space, focused on things like algorithmic trading, crypto trading, and options trading. But throughout the past year, we've introduced new topics, more of newer industries and disruptors like blockchain, Web3. And following along with many of our other machine learning and Python courses, we've introduced this unique one here, brand new, coming in February. We will be posting this recording on YouTube and Circle, along with other videos that we have up on YouTube already. Like some of our other webinars, we also post reviews from some of our students and extra tutorials, interviews. So please subscribe to us on YouTube. You can just search for Lumiwealth, and you can watch back and watch some extra supplementary material. To watch this live, of course, you have to be on Circle, as are some of you today, lumiwealth.circle.so. We do still have Discord if you want to find us there. Our primary community chat is at Circle, but you can still find us on Discord if you'd like. All right, so now that we've introduced tonight's agenda, some of you, and Lumiwealth, let's dive into our first topic, talking about Excel, where this all begins. All right, so week one of our course, we will be talking about Excel, because Excel really was the forefront of modern data science. So we will cover it because many data scientists today, they're transitioning from Excel to Python and coding. So week one, we will be using Excel. We'll do some basic machine learning in Excel. This is called linear regression. This is one technique, and we'll talk more about this later on tonight. Now, linear regression, maybe some of you are familiar because it is inspired or comes from statistics. So there's different ways of doing linear regression with machine learning versus with statistics. So week one, we'll look at the origins of machine learning in Excel. After that, however, we will be using Python. So we're moving away from Excel, we're still working with Excel data. You know, you can work with Excel files, CSV files, if that's your data that you have, your file type. But instead of working with it in the Excel application, we'll be working with that data with Python. So week two, week three, we'll learn how to do data science and machine learning on our data with Python. We'll talk more about all these new topics, likely new to you if you have no experience before. We'll talk more about that tonight. So Excel. Why are we moving away from Excel? What are the limitations? So I assume most of you have used Excel before. Let me know in the chat. Excel is a very popular program for storing data through Excel files and CSV files as well, related, as well as analyzing data, performing formulas on the data, so manipulating the data, maybe doing statistics, some automation. Perhaps you're using extensions like Power Query, Power BI, Visual Basic, VBA for applications. So there is some automation, some coding that you can do in Excel. Of course, there's formulas that you can write. Maybe some of you have built projects in Excel, like analyzing the data to make a prediction on the budget, or keeping track of data that you have, finding percentages, making reports. Perhaps some of you already have experience with data science, working with data in Excel. But these days, as a modern data scientist, Excel has limitations. Number one reason is data volume. Now, as you have large amounts of data sometimes called big data, which just means a lot of data. The ability to handle it in Excel decreases. Where Excel does have data volume limitations, in general, it just gets tedious to look at it in Excel as well, or to work with these huge Excel files directly in the program. Related to that is speed. How quickly can you run things like formulas in Excel on a lot of data? How quickly can you run algorithms, which means like automations in Excel? When I talk about speed, I'm also talking about you as the developer or the data scientist, the engineer, the analyst, whatever your job is or you want to be, your speed as the worker. How quickly can you build these automations in Excel? How quickly can you analyze the data in Excel? We see some limitations with speed in that sense too. So how fast the programs, the application is running, and how quickly are you working as well. We also see security limitations in Excel. Your data is being stored in the Excel application. So are your formulas, so you are relying on Microsoft in that sense. Another limitation are the algorithms themselves. As we will see in week 1 of our course, you can do some machine learning statistics as well in Excel. But for a higher level of machine learning, and we'll talk more about that tonight, but in general, referring to artificial intelligence, for those of you that don't have experience with machine learning, you can call it artificial intelligence for now. For building these algorithms, which means code or automations written with code, or even just automations that you create in the Excel program, there's limitations with those as well, with the kinds of algorithms that you can build. The limitations for the algorithms are the sense that how complex can you make them in Excel, and how convenient is it for you. So because of all of these issues or limitations, you can call them, we see a transition away from Excel, or in addition to it, learning Python or coding as data scientists today. So that is the goal of this 8-week course, is to teach you how you can become a data scientist for the modern day using programming specifically for data science and machine learning, because there's tons of types of coding that you can do. This course is focused on coding for data science and machine learning. So how do we get past these limitations? Do we just live with them, and do we just use Excel? Well, no. Instead, we adopt programming languages. The most common ones today for data science are Python and R. In this course, we are going to learn how to use Python. So we'll look at what can we do with Python on Excel files, on our data that we would typically work with in Excel. How can we work with it in Python? Now, if you're thinking, why do I have to work with it in Python? Why can't I just keep working with it in Excel? Well, back to those limitations that we talked about. These days, you're expected to know how to code as a data scientist so that you can surpass the limitations of Excel and in general just be more efficient, because when you're working with data through code, well, you can analyze it much faster in terms of how quickly the analysis is done and how quickly you are building the system that will do the analyzing. You can also build more powerful projects. So you can build things like facial recognition, where you're analyzing data of faces. That's quite a powerful project, requires, complex machine learning, and you need some kind of code or software that can handle the data that you're using, the facial data and the system or the code that is working on that data. So Excel has limitations in the types of projects you can build. So then that's another reason to turn to a programming language. Especially for data science and machine learning, if you want to be a machine learning engineer, or if you want to just work in the machine learning field, you have to know how to program. We also see larger incomes for Python developers or Python data scientists compared to data scientists who only know Excel. And Python is completely free. Free to use, free to run, whereas Excel, we see free trials, but it's paid. Python is also open source. I didn't put it on this list, but it means that it's not owned by any company, whereas Excel is owned by Microsoft. So these days we have to know both. We have to know Excel, but we also have to know more advanced tools for the nature of data today, the amount of it, and because you're going to be handling a lot more of it as a data scientist today. And also the types of projects that we build today. Data science projects, machine learning projects, they only get more advanced each year because there's more research and more innovation done. So that is Excel versus Python. Now, Excel is an application. It's a program you can launch. Python is not an application. It's not a program. It's a programming language. So a coding language. So there is a difference between the two in that sense as well. Our next topic is data science in general. So perhaps some of you already work with data today in Excel, but for those of you that have never worked with data in general, let's talk a bit about data science. When we talk about data science, we're talking about working with data. So organizing and analyzing data, and it could be a small amount of data, usually for beginner projects, but at companies, you're likely working with a lot of data, massive data. Now, this is a large range data science. This could be collecting data. This could be generating the data, creating it, or gathering it, collecting it, scraping it. If you're analyzing social media data, for example, you have to get the data from the social media site. So that could be data scraping. It's all part of the collection phase or section. Data maintenance, where are you storing it? Are you updating it? Data processing, so what are you doing on the data? Data analysis, can you understand the data? And also involved in that is data cleaning. That's part of data collection, data processing, removing missing data, removing irrelevant data, irrelevant fields, cleaning up the data. More often than not, the data that you collect or that you get assigned to or that you're using, it's going to be messy, it's going to be noisy, so it's going to have issues. So you have to clean it as part of the data science stream or process in general. Data analysis. So can you understand the data? Do you know what you've collected? Can you add labels if you need labels to your data? Can you do this with automation, with automated tools, rather than manually labeling all of your million samples? Can you write code, write a system that will go through your data and label it all in 30 seconds instead? That's the whole goal of this course, is to teach you how to automate a lot of these data science tasks and to go beyond that into machine learning as well, which we'll talk about next. So data analysis, that's another part or branch of the data science stream. And can you get predictions from your data? Can you do statistics? Can you get any information from your data? You might get a bunch of social media data. Maybe you have 1 million different tweets, But then what are you going to do with them? Are you analyzing them for sentiment? Do you want to get the overall sentiment about a product from social media? Or do you want to predict how a company will perform based on that data, based on all those social media posts? Or are you just getting language data so that you train your system to learn a language or to generate its own social media posts? What are you doing the data with? What are you doing with the data? As part of data analysis, and also goes into machine learning, artificial intelligence. So that's also part of the data science umbrella. What can you do with the data? And data visualization. Can you build charts from the data? Can you show trends in the data visually? Can you tell a story with the data for others on your team if you're working with a team, or if you are just publishing your project or getting funding for your project, or as some of you are in college or college professors, showing your results to students, to an audience, to people who don't understand coding or even data science in general. Can you make it easy for others to understand what your project is? So as a member of a data science team, you might just be in charge of one of these bullet points. You might just be in charge of data collection, or even smaller than that. Or you might be in charge of the whole process. It really depends on the project you're working on. Are you working on a project by yourself on the weekend, or are you working at Google as a data visualizer, data visualization specialist? So that is data science in general. Very closely related to data science is machine learning and artificial intelligence. And that's what we'll talk about next, because in our 8 weeks, we are going to learn covering some Excel, Python, data science, and machine learning as well. So again, you can look and see in our curriculum around week 3, we will begin working with machine learning. Right? Then we have data science and machine learning part 3. So we cover a huge range of topics in these 8 weeks, from Excel, statistics in Excel, data science in Excel, to data science in Python, and then more advanced projects. Once you do have the coding knowledge, you can build more advanced projects with machine learning. So the reason we have this huge range of topics is because they are all related. They're all in this umbrella of data science, and they are all in general just about working with data. And there are many different avenues that you could go down. Sometimes you're working on all the avenues. You have to have Excel, you have to have Python, you have to have data science, and you have to have machine learning in your project. Really depends on your role. Are you starting your own company and you're in charge of everything, or are you just in charge of a specific section? But a lot of times all of these things are working together in one project. So our next topic is machine learning, very closely related to data science. So we will learn how to build machine learning projects in this course as well. We'll learn data science projects and machine learning projects. So you can let me know your goals today or later on, whatever you'd like, because in this course, the result that you could come out of are a bunch of different streams. Now, you could focus on data science if you want to be a data scientist. You could focus on machine learning if you want to be a machine learning engineer and work in artificial intelligence. You could just focus on Python if you just want to work on coding in general. So if you let me know your course goals, that will definitely help me tailor my webinar and my courses for you. But we will also cover machine learning. So machine learning is a subset of artificial intelligence. So it is one small bubble under the large bubble of AI. And as a machine learning engineer, you will find yourself using data science a lot. So all these things that we just talked about, the collection, analysis, visualization, those are often part of the machine learning process as well. When you build an AI project, you're often, well, almost every time really, you're going to be using data science in it, because AI, and therefore machine learning, it is built on data. It cannot run without data. So all these fields are very closely linked. So what is machine learning? What are we talking about? One definition, one way of defining is computer algorithms that find patterns in data to make predictions. Computer algorithms referring to code, so it's running on its own like an automated process or a script or a robot, and it's running independently. So you will write the algorithm, you will write the system, you'll build out the robot in a way, and then it will perform, or it will work on its own. Kind of like training an employee, and then the employee will go and do the work. And the reason that machine learning is not just any other algorithm or any other app or any other program or system is because the goal of the algorithm is to learn on its own. So not only am I building a robot to, vacuum my house, which that very often uses machine learning, not only is the robot cleaning my house because I taught it how to move around, but it's also learning from experience. And that is what makes the algorithm machine learning. And that's what makes it so powerful and useful, is because you don't have to tell it exactly what to do. Many times you just have to design the structure, and then you send it to learn from experience or learn from data. And then the algorithm itself will improve its job or whatever goal you have set it. Like the robot that's cleaning my house, it will learn how to clean the house better because it will learn from its experience. That's one example of a machine learning agent. So sometimes they're called agents. If it's a physical thing like a robot, it could be called a machine learning agent. If it's just a script, it's often just called a machine learning algorithm or machine learning model. All of these are referring to the same thing, a computer algorithm. Because a robot might be a physical thing, but it's all working with code. So at the end of the day, it's still an algorithm. And the algorithm, the robot, it's learning to perform better. So it can clean my house better or whatever other project you have. And you don't have to go in and change it in any way. I'm not going into my robot and telling it, to changing up its system. I mean, I could, but I don't. That could be part of the process, is improving it yourself. But the whole point is it can perform better by learning on its own. And it either learns through its experience or through the data that you give it. So if I give it some data, it will learn from the data. And then if I feed it more, it will learn more and more. So many different examples of machine learning exist. It's a wide field with many applications. For example, image recognition, recognizing what is inside of an image, like facial recognition, detecting people in an image, and then beyond that, specific people, who is in the image. That is a task that uses machine learning. The data in that case are the images, and the model or the agent, the algorithm, whatever you want to call it, it's learning from the images that you feed it. It will learn how to recognize what is inside of an image based on the patterns of previous images. Another example of machine learning is in self-driving cars, detecting lanes, detecting pedestrians. All of that is in the field of computer vision, which is teaching computers how to see the world around them. So through a camera, the self-driving car will get the data about the road. The data is just the image or the video of the road. And that is fed to the model. The model learns where the lanes are, and then it can detect lanes on the road when you start driving the car. So the developer has to train the model by giving it the video data of a whole bunch of roads. It could be millions or maybe thousands of hours of video of roads with lanes. That way the model learns the pattern of images that have lanes. And then that model is used in a self-driving car so that the model, when it gets a new road, when you drive out, then the model is trained to be able to recognize lanes. The way that the model learned that is through the data that the developer gave the model. So before you start driving your self-driving car, or before it drives you rather, the model has already been trained. It already knows how to find lanes. And then you're just giving it a new video stream. You know, it has a camera and it's going to detect the new lanes that you go down. Another example of machine learning is recommender algorithms. So we often see this, not always for recommenders, but because there are other ways of building recommenders, but it is one way of doing things like ad recommending, video recommending. See this a lot with machine learning models because they generate a profile of a user based on the user's search history, watch history, their entry history, what they typed. And so you have this profile of the user based on what they already visited. And then the machine learning model will find patterns between all the different people. So maybe you have a million people, a million profiles describing a user based on what they searched, what they watched, what they clicked on, whatever data you're using about the people. The recommender algorithm will find patterns among the people, and then therefore it can recommend you a video if you are similar to others that have watched that video. So again, the model is just code that is learning to find patterns in data. With all these projects, it's all about finding patterns in data. Another example is with translation, translating languages. Machine learning models can do that as well. There's a huge range of projects from simple to complex. You see deepfakes, generating images, generating videos. Machine learning models can do that as well. They're trained on existing videos, and therefore they learn the patterns in videos, and then they can generate their own videos. So it's another example. Speech to text and text to speech. Machine learning models can do that as well, where you will feed a model a bunch of text and speech for that text. The model will be able to find the patterns between the two. And then if you feed it some new text, it can generate for you the speech for that text because it has learned how to speak. What it's really learned is how to match words to the audio files. And then it can generate new audio files. Or the opposite, it can generate text from the audio files. So those are a bunch of examples. I'm not sure what field you are all in, what you're interested in, but across every field you can implement machine learning. Any field that has data. So if you're working in video games, you can use machine learning to control the objects or players or bots in the video game. If you work in marketing, you can use machine learning for recommendations, targeting. Just in general, you can use machine learning to gain insights on the things that you can learn from your data. Because if I have a bunch of data, maybe about my customers that have purchased products over the past year, Sure, I could look at the data and I could make a chart. Oh, 100 people bought this, no one bought that, 1,000 people bought this. But if I want to uncover more insights, more patterns, it's hard for the human being to do it quickly and just to do it in general. So with computer algorithms like machine learning algorithms, you can find patterns that much harder for a human to find, or just much slower as well. So very important and useful field. Machine learning, there's still a lot of research and innovation that's being done, because as you build more complex models, machine learning can get complex, can involve a lot of math and just in general complex programming. But the good news for you beginners is that you can still start with beginner projects. So you don't have to jump in and build your own deepfake generator. You can start simple and work your way up. There are beginner machine learning projects and complex ones. So in our course, we'll start with the beginner ones. And as you learn more and more, you can build more complex projects, more advanced machine learning projects. So I have some images here to represent some projects that you could build. So this is a very simple example. This is an example of linear regression, just a general cartoon event that I've made. And we'll take a look at more of this topic tonight. But this is just a best fit line. So this is the simplest of the machine learning models because they're different types. You have all these different projects, you have all these different types of machine learning models. This is a more simpler one called linear regression. And those of you familiar from math class might remember a best fit line. So you have a bunch of data. This could just be an Excel file with X coordinates and Y coordinates. X coordinates on this axis, Y coordinates on that. Maybe you collected it from a biology sample or from stock prices, or you just generated it randomly. Whatever data you have, it could be in a whole bunch of industries. You can plot it on a graph, sure, but what if you wanted to find the trend in the data? Like if you want to predict how a stock will perform, you have it performing on Monday, Tuesday, Wednesday, Thursday, Friday. You want to predict how will it do next week. Well, with making those kinds of predictions, you need to learn the patterns in the stock. Of course, it's not a perfect science working with stock prediction, but you can use this best fit line to predict the trend. So that we see that same kind of principle in all these different machine learning projects, where you have existing data and you have to find the patterns in it to make predictions about new data that you could get. So this best fit line, it's showing you the trend in your data. There's a general upward trend. This machine learning model comes directly from statistics and linear algebra. But we see many more complex models that are separate from, just a best fit line. This is just a beginner example. So the machine learning model will generate this equation of the best fit line. All you have to do is give it the data. The model will find the pattern in the data. The pattern in this data is this line because it's the trend. Now, a pattern in other data, like this data, the pattern is cats. So each project is different, but we have the same underlying principle. In this sense, in this case, your data is an image. And the pattern that you're looking for is what objects keep appearing in the images. In this case, a cat. The model, you will train it on no longer data points, but in this case, you're going to train it on images. Maybe there's cats, dogs, turtles in all the images. The model is going to get either labeled or unlabeled data. It depends on the project, which means that you might tell it how to find a cat, or which images are cats rather, which images are dogs, which images are turtles. You might label it, or you might not even label it. And then the model will have to find the pattern by itself. So how would the model find the pattern? Well, there's different techniques. One way is finding the outlines, because a cat will have a different usual outline than a turtle. So that's one way that the machine learning model learns to differentiate between cats and turtles, is the difference in the outlines that will be in the image. So the data is really just pixels in the image, and what color are the pixels, or what intensity are the pixels in terms of shade, or what color are they. So two very different projects, but these are both machine learning projects. So in this project, linear regression, your model will give you a result. The result is this equation that you can use. And if you give it a new data point, you would be giving it the X and it would tell you the Y. So you would give it, for example, the stock price, the day, like February 1st. That would be the X, and then it would give you the stock price, which is the Y. So you train it on like a whole year of days and stock prices, and then you want to predict tomorrow. Well, you give it the day and you plot it on the line. So if you see that the trend is going up in the previous data, then your prediction using the model, your prediction is that the stock will keep going up. You make that prediction based on the previous data. And the model is giving you an equation so that you can put the stock price to this overall average of the previous days. With this project of object detection, you would train the model on maybe 100 or however million images, however many you have. The model will learn how to recognize cats versus dogs versus turtles. Then you can give your model a new image and it will predict, is the image showing a cat, a dog, or a turtle? And it will also give you the confidence score, like 90% it's a cat, 10% it's a dog, 0% that it's a turtle. So two different projects, but they're both finding a pattern in the data and therefore giving you this model that can make predictions on new or future data. Similar idea here, object detection with a confidence score. So in this project, my model was 98% certain that this was a dog, 94% certain that this was a person, and 99% certain that this was a cat. Another application is for clustering. So let's say you have a bunch of data points that you've collected from samples, maybe in a lab for this example. Well, when you get data, it's really just a bunch of data points on a grid. How do you know where to separate the samples? Because there's many different ways that you could split these up, and especially this example too. How do you know that there's all these different groups? Well, the model can learn to detect where a new sample should be, which group it should be in. The model can also separate your samples into groups on its own. So if I have 100 different samples, the model can tell me by finding the patterns in all those 100 samples, it can tell me, okay, there are likely these 4 groups, these 4 different species in your 100 samples. Another example is a logistic regression model. So there's all these different types of models you can build. Logistic regression, one project would be for loan approval based on features about a person, like their income. And so you have these different points of income. So from low income to higher income on this x-axis. The model is going to predict, will that person get approved for their loan, maybe their mortgage? Will they get approved for it based on their income? So it finds this divide where odds are if your income is below here, you will not get approved. Whereas if your income is up here, you will get approved. Now, usually we see a lot of features working together. We don't just see income to predict your loan. So the model can handle multiple features. So you could give it 10 different features about a person or a profile, and the model will predict based on those 10 features, will the person get approved or not? So that's another example of another project. Now, in code is how we build these projects. So I have one example here of a project, and I will drop a link in the chat to this project. Now, I don't expect you to understand any of this code because, as most of you have mentioned, you don't have coding experience or you have minimal coding experience. That's totally fine. We will teach you how to code from scratch in our course. But here, this is a website called collab.research.google.com, built by Google. This is one way that you can run Python code. So what you see here is a bunch of code specifically in the Python coding language. And this project is how you can build a simple linear regression machine learning model. So this one right here, this cartoon, just to visualize this kind of project, is what I've created here on this file. And you can see the different sections here of code. This first section of code imports some helper libraries into the file. So when you're building a project with code, you're often going to use some helper code in your project. So that's the goal here. We're importing NumPy, which is used to format and store data in code. We're importing linear regression, which is code for the model structure. Now, you could make your model completely from scratch if you'd like, or you can use this predefined structure, kind of like a template written with code. And then another library here is for visualizing the data. So all of these libraries, they're written with Python code, and they're like extensions to Python that you can use to do extra tasks. So here we've built the data that we're going to use for this, to train this model. Now, this is just a sample, but usually you have the data as some kind of file or a folder of files, like you'll have an Excel file, and you're working with that data. In this case, just for simplicity, the data is just a bunch of numbers in the code. So that data, oops, that's the YouTube channel, that data is all these data points. You have the X coordinates and the Y coordinates. So you have, oops, for the first one, you have 5 as your X coordinate and 5 as your Y coordinate. The second sample has 15 as the X coordinate and 20 as the Y coordinate. So this is the data that you're going to use to train your model. Usually it's a lot more data, and the data could be other formats. It could be videos, it could be images, it could be sound files, it could be 3D models, it could be text. Right? In this case, I just kept it simple. So to show you just the general structure of a project, you have your data. Now, usually in a machine learning project, the first step is to do some data science. That's why, again, in this 8 weeks, we cover data science and we cover machine learning, because they work hand in hand, very closely related. First, you'll have your data. It could be a million images or whatever you're working with. And you might have to clean it, might have to format it into code like we have here. You might want to visualize it so you get a sense of what you're working with. So in this case, here's a visualization of this data. So it goes on this trend, right? So this is the original data trend. You can see some points like 5, 5, 15, 20, 25, 14, 35, 32. So we see these coordinates appear here on this line graph. Oftentimes you'll visualize the data, analyze it to get a better idea of what you're working with and what can you do with the data. Because there's a bunch of different types of machine learning that you can do. Linear regression, polynomial regression, decision trees, classification, object detection, self-driving cars. With the data, you have to understand it to be able to decide what to do with it. So once you understand your data, done some data science, then you can build your machine learning model. And you can train it on your data. In this case, it just took 2 lines of code to build the model and to train it. Of course, projects get a lot more complex, but some projects are very simple. So this is just to show you that you can start simple. Just 2 lines of code, you've built some artificial intelligence, which is machine learning model. This fitting means that you're training the model. Training the model means that it learns the patterns in the data. You give it all this data and it will find the pattern. What is the pattern here? Well, it's this trend that I had right here, this best fit line. That's the pattern. The pattern in this one is cats versus dogs versus turtles, dogs versus people versus cats. So when you fit a model, you're training it, and it's all down to equations. The model will have an equation that represents the relationship between X and Y in this case. With other models, they get more complex. They have different layers. For example, if you have a neural network, then you won't just get a line, but you'll get a lot of lines. And the lines are really equations. But in general, when you're training a model, it means that it's learning how to describe the relationship between X and Y, and how to match X with Y. In this case, how to match the X coordinate to Y, how to match a day, like February 1st, to a stock price, or how to match some pixels in an image to a cat. How to match this image to a cat, this image to a dog, this image to a turtle. It all comes down to equations because the model is just code. And it's a formula that describes the relationship between X and Y, the input and the output, the independent variable and the dependent variable. So in this example, the model's job is to find an equation that can describe the relationship between income and loan approval. That way, if you get a new person and they give you their income, and usually it would also include a lot more features as well, they would give you their profile and you can use the model to make a prediction. Would this profile get approved for a loan? Because the model has learned how to describe that relationship between the profile and loan approval. Then you can evaluate your model for accuracy. So here we're scoring the model, get about 70% accuracy in this case. You can also get model values because the model is an equation. In this case, it's a simple equation. Maybe those of you that are familiar with math, y equals mx plus b is this equation is to describe a best fit line where you have the slope, which is m, and you have the intercept, which is b. So it's just describing this line right here. The slope is referring to how it's angled. So is it angled like that, or is it almost flat? That's the slope. Then the intercept refers to where does it collide with the y-axis. So is it up here or is it down here? That's the intercept. So the equation is the line. So you can actually see the details behind this equation. The x and y, that refers to your data. So the model will give you an equation of how to start at x and get to y. How to start at March 1st and get the stock price. How to start at an image and get a cat. How to start at income and get loan approval. The model gives you an equation. This is a simple type, but they get more complex as you build more complex models. But this is a model that has told you how to start at X and how to get to Y. How to start at some words, some written text, and get to an audio file of a robot that's speaking the text. Or how to start at a video stream and get the lane detection of where the lanes are so that the car stays in between the lines of the lane. Or how to start at an image of a face and recognize the person in the image. Okay, all these examples that we've talked about. So you have this model and you can actually see exactly what equation it came up with. I never told the model this is the equation. It's nowhere here in this code. The model generated that equation for me by taking this data and telling me the average relationship between X and Y. Of course, if my data was a perfect straight line, then I would get 100% accuracy each time. But because data is usually messy or a bit random, it's not going to be perfectly on a straight line. When I invest in a stock, it's not always going up like this day by day by the same exact amount each day. No, usually the real world is more volatile and data is more varied. So that's why our model in this case only has 70% accuracy. Number one, because we are building a simple example, and number two, because the data itself is not a perfectly straight line. This original data, it looks like a mountaintop, it's jagged. So the data cannot actually have a perfectly straight line. Therefore, our accuracy is not 100% because we're trying to put a straight line into something that's not a perfectly straight line. But that's just the nature of data. You can build other models, like you can have a curved line, like here. This is a different type, but you could have a curved line or not even a line itself if you get into neural networks. But the point is that we have a general best fit line going through the data. So we get our most accurate prediction that we can get using this type of model, which is just this straight line. So maybe the model is always going to predict on this line. So it will predict tomorrow's stock will be up here. Maybe tomorrow's stock will actually be a bit higher because it will not go perfectly as expected each day. So then you can test your model on some new data. So here I'm giving it this new data, these new samples, and I'm saying, give me a prediction. So this time I'm not giving it the Y, I'm only giving it the X. And I'm saying, hey model, give me a prediction for maybe stock price in this case. And it's going to give me a predicted response. And then you can visualize the predicted response. So this is what it predicts for my data for the 2 and then the 3, 23, 324. It tells me for each of these values what it predicts the Y for that X. And you'll notice this time it's a straight line because our model type is called linear regression, which is linear. It can only do straight lines. You can build other models if you don't want straight lines, if your data is more complex. But in this case, we built a linear regression model, which means the model will always be linear. So it will always give us this prediction of this trend, some kind of line. But depending on the data, it will be a different line each time. You know, my data, my line and my data, they might be down here for another project, or they might be up here. So the line will adjust to fit whatever data you have. So just like that, you have your first project of machine learning. Now, in our course, you'll be able to understand each line, so you won't have any questions about any of this code. Right now, I don't expect you to understand the code because most of you don't have coding experience. But by the end of the course, the goal is that you can understand this whole project, you can build a similar project, and you'll have the tools to build more projects beyond the 8 weeks. You'll be able to continue finding your own data, building your own projects in whatever industry or project of machine learning that you want to create. And you can access that link anytime if you want to see that project again. Next, let's talk about our 8 weeks. What will you learn exactly? If anyone has questions, you can also ask away. I want to tell you that there is a coupon code that you can use today, Laney23. That will expire on Friday, but it's 25% off any course. So here, let's go through the course page talking about what you will learn. So in week 1, we'll begin in Excel, looking at the origins of machine learning, which is inspired from math, statistics, and data science, but it is its own field, machine learning, with its own unique abilities. Week 2, we will start coding in Python. So you will learn how to code from scratch. Week 3, we'll start looking at machine learning. So we'll talk about Python machine learning more in depth and get more specific about how these models work, what the code means, so that you understand everything at a more detailed level, because tonight there's only so much we can get through. Week 4, we'll learn how to do data science working with Excel files in Python. So you'll see how much more you can do faster when you combine Excel with Python, combine your Excel knowledge with coding, and therefore more automation. So week 5, week 6, we'll learn more about automating Excel tasks and how to do more beyond what Excel is capable of in Python. And then week 7 and 8, we will build more machine learning projects and talk about where you can go from here, the different avenues you can go down if you want to specialize in general coding, data science, or machine learning, and how you can expand your portfolio and do more research and keep growing your portfolio and building projects, preparing for the software developer interview, the machine learning interview, if you are looking for a job in the space, or just building your own projects and startups from scratch. So 8 weeks with tons of projects throughout all the 8 weeks. And this course begins at the end of February. We have 3 different options for taking this course. The first is the self-directed plan, where you're studying on your own, but you get access to our video library as we record each week. You also get access to our library of code and projects, to the community and instructor support. So that is the self-directed plan. Now, we've never run this course before. It is brand new, so there's no existing video library yet, but we will be adding each week to the video library, and you get lifetime access, so you get every semester that we create. So you're a student for life here at Lumiwealth. The other option is live classes. So you get everything we mentioned and also meet live every week for 2 hours where we go through the curriculum. We build projects live. We do live debugging. So if you have an issue with your code, we fix it right away. You can share your screen. You can ask questions. Very interactive, this live classes option. You also get 6 hours of live Q&A, help with personal projects, resume prep, interview prep, and unlimited email and chat support. And the final option is project help or tutoring. If you have a specific project in mind or you want one-on-one tutoring, then that is the option for you. You get everything we mentioned and also help building a custom project and 10 hours of one-on-one video or phone sessions or software development time. So if you have a specific company you want to start or project you want to build, or you just want extra tutoring time. And for each of these, we have payment plans available. So you don't have to pay at once, you can pay over time. And we have invoices that we can provide as well for employer reimbursement. To sign up, you just pick one of these, like the live classes, for example. Live classes option begins at the end of February. And we meet every Tuesday at 8 p.m. Eastern Time, which is 5 p.m. Pacific Time. The effort depends on your course goals and your prior experience. If you want to just watch along, that's totally fine. If you want to do the optional homework each week and challenges, then it will take more effort. If you have coding experience, that will also make it easier for you. If you're brand new, it will take more effort because you're brand new to all these topics. So you can select a course and this will take you to the cart. So here you can pick a course, you can apply a coupon code. As we mentioned, we have one running today. If you add another course, then you'll automatically get 10% off. And then you can proceed to checkout. And just like that, you'll have access to the video content, the code, the projects that we already have up for the courses that you've already selected. For Excel, it is brand new, so we are still building out the library, but for other courses, we have huge libraries that you can instantly see with years of videos. So you can choose to pay with a payment plan if you'd like. You don't have to pay all at once. And then you can place your order, and that is it. That's all you have to do. If you'd like to speak with us over the phone, then you can book a call right here through this page. I'll also drop a link to our support email. You can also message us on Circle at any time. You can make a public post or send us a direct message. We're happy to talk on the phone or talk over email, whatever you'd like. So if you have more questions, you can ask now or you can talk to us later live. We will be posting this recording on Circle and on YouTube, so if you'd like to watch back, it will be available for you to watch again. Does anyone have any questions about the course or Excel, Python, data science, machine learning? Feel free to ask away. You can also message us anytime online if you can't think of any questions on the spot. Remember, you can catch the slides and download them for future reading if you'd like. We'll have tons of resources available once the course begins in February. If there are no questions, I hope you all had a great time. I had a great time introducing this new course, our first webinar on Excel, Python, data science, and machine learning. I had a great time introducing you all to these new topics to Lumiwealth. We have other Python and machine learning courses too here at Lumiwealth. So if you're interested in this topic and you want to learn more, check out our webinars on crypto trading, algorithmic trading, options trading. These also are in the same realm of Python. Machine learning, of course, are another course we have too. So check out our upcoming webinars. We'll have tons more here on Circle in all these different courses. So if you want to learn more about any of our courses, then just stay on Circle and keep posted. Many evenings we're doing these free webinars all the time. And feel free to come back. I hope to see you again sometime soon, either in another webinar or in February when we begin this course, Excel, Data Science, Python, and Machine Learning. I hope to see you for that winter, spring semester. More of spring. So yeah, it'll be a great time. Thanks so much for joining me and participating tonight, all of you participants. If there's no further questions, then we can call it a night. We've covered some topics that we will dive much deeper into in the course. We also looked at a simple introductory project just to give you a taste of the kinds of projects that you will build in the course. Thanks so much for watching, everyone, and I'll see you next time.